Sai Ram students, welcome once again. As we are on chapter number 3 of science A, that is chemical reaction and equation. Okay, so far we have studied many topics in this chapter. Okay, today we are going to start with the last topic of the chapter. Okay, if you remember the previous presentation, we have studied about oxidation, reduction, and redox reaction. You remember? Let's have a recap. Oxidation means gaining of oxygen or loss of hydrogen. On the other hand, what is reduction? Gaining of hydrogen and loss of oxygen. And what was a redox reaction? When oxidation and reduction takes place simultaneously, that was redox reaction. Okay, these three basic concepts we have studied in the previous presentation. For today's topic, we are going to use those concepts also. Okay, so our today's topic is corrosion. We are going to understand what is corrosion. Okay, and for that we are going to see one activity. Now here in this activity we have taken 4 test tubes. Okay, and we have to add one iron nail in each of the test tube. You can see on the screen 4 test tubes, and in each test tube there are 4 in each test tube there is one iron nail present. Now let us see what solution and what chemicals are being added in the 4 test tubes one by one. See, in the first test tube we have to add boiled water, and from the top then you have to pour some oil so that a layer of oil is formed on the test tube. As we all know, the density of oil is lesser than water, so oil will float on water, it will not get mixed, and that means boiled water, and then you have to pour some oil, so the test tube is covered with the layer of oil. Okay, this is about the first test tube. In the second one you have to take some salt water. Okay, that means salt solution. In water you have to add some salt, and that solution we are going to add in this test tube. Okay, in the next one we are not going to add anything. Let the test tube be vacant. Okay, so the atmospheric air only will be present in the test tube, nothing else. Okay, then in the last test tube, in the fourth test tube, some amount of anhydrous calcium chloride is been taken, the powder of calcium chloride is been taken, and some atmospheric air will be definitely present inside it. Okay, and we have to cover it with a rubber cork. So we have taken 4 test tubes. In the first one, now you can see, in the first one we have taken some boiled water and oil. In the second one, salt solution. In the third one, nothing, only air is present. And in the fourth one we have taken anhydrous calcium chloride. Okay, we have to keep this 4 test tubes aside unattended for a few days. After a few days, when we observe the 4 test tube, what we are going to see that the iron nail which was present in the test tubes with salt solution and air. Okay, see this one. That means the second test tube and the third test tube. Okay, in the second test tube we have salt solution, in the third one only air is present. So here in the second and third test tube we are going to observe that the iron nail will get rusted. Okay, that means a reddish brown color layer will develop on the iron nail. That means the rust will be formed. Now what will happen with the iron nail which is present in the test tube with boiled water and oil? So if we observe that test tube after a few days, we will see that the iron nail which is present in the test tube with boiled water and oil will not get rusted at all. The nail will remain as it is. Okay, and as well as in the next one, that is the fourth test tube in which anhydrous calcium chloride was present. Okay, in that also the nail remains as it is. Now what is the reason behind it? Why these two test iron nails in these two test tubes of calcium chloride and the one with oil, why they are not getting rusted and why the other two are getting rusted? So the reason is, for rusting two basic things are required, that is air and water. If both the things are present, air as well as water, iron material gets rusted. Okay, in this case, in the case of salt water, salty water increases the speed of rusting. Okay, you remember the boats or the ships which are present in the oceans, in the sea water. As we know, the sea water is salty, isn't it? So they get rusted very oftenly because salt water increases the rusting. Okay, so as air was present, water was present, it got rusted, the nail got rusted. In the second case, air, where the test tube was vacant, only air was present. In that case also, if, we all know in the air some amount of moisture is present. Okay, so that moisture and air has reacted with the iron nail and the iron nail got rusted. But in case of the test tube which was having oil present in it, as we have poured oil on the top of the test tube, so oil had prevented the air to enter into the water. So it was only water present in the test tube and no air present. Because of that, as we know, for rusting two things are necessary, air and water. So air was not, like water was present but air was not allowed to enter because of oil, so the nail did not get rusted. In case of anhydrous calcium chloride, we had covered it with a rubber cork. So whatever air was present in the test tube, okay, that was absorbed by the anhydrous calcium chloride. Okay, so as there was no air present in this test tube, the nail remain as it is. That means it does not get rusted. Okay, so now from this, let us see the definition of rust. So you can see here, what is rust? A reddish colored solid layer that collects on the iron material is called as rust. We have seen, it's a basic example. Okay, we have seen various window grills, okay, that get rusted. So we, when we observe it, a reddish color layer is formed on the iron nail. So that reddish color solid layer that collects on the surface of the iron material, that is called as rust. Okay, and its chemical formula is Fe2O3 dot XH2O. Now what do you mean by XH2O? X means the number of water molecules. The number of water molecule in the rust is not constant, it can vary. Okay, so that is why X is written over there, depending upon the amount of water present nearby. Okay, so it depends. So the number of water molecule may vary. That is why X is written, but the basic formula remains the same. That is Fe2O3 X H2O. Here X means the number of molecules of water. So this is the formula for rust, which you have to keep in your mind. That is very important. Now this rust is not formed by a simple reaction. It is not a simple reaction as it looks like. As we know, rusting is a slow process, isn't it? When we observe the window grills of our house or our school window grills, so it's a slow process. It is not like one day the water one day you are watching that the window grill is good, and the next day it cost start gets rusted. It is not like that. It's a slow process, and it is not that simple as we think it is. It's a electrochemical reaction. Okay, the rust is formed by a electrochemical reaction. Okay, different regions on the surface of iron becomes anode and cathode. Okay, we all know what is anode and cathode. In 9th standard we have done this. Okay, the positive, if you remember the electrochemical cell, okay, in 9th standard we have done the positive terminal and the negative terminal in the electrochemical cell. Okay, one acts as a positive terminal, one acts as a negative terminal. Okay, the same on the surface of the iron material, some region acts as the anode, that means as the positive terminal, and some regions acts as the cathode, that means as the negative terminal. Okay, so now we are going to understand how this rust is formed. Okay, okay, as we all know, the formula for iron, that is ferrum, is Fe. First, Fe gets oxidized to Fe2 plus in the anode region. Now you remember we have done this part in the oxidation and reduction presentation. In the previous presentation I told you that will be useful here. You can see here Fe is oxidized to Fe2 plus. We have seen one more definition of oxidation, that was loss of electron, was oxidation, if you remember. So here Fe is oxidized to Fe2 plus. That means iron has lost its 2 electrons, and as it has lost its 2 electrons, so it becomes Fe2 plus. This happens in the anode region. So the reaction you can see downward, it is given Fe, okay, that is solid, iron surface is solid, that is getting oxidized. That means it is changing to Fe2 plus, and 2 electrons are getting released. And where this is happening? In the anode region. That means on the iron surface, somewhere on the iron surface, one particular region becomes the anode region, and there this oxidation takes place. Okay, somewhere on the iron surface a cathode region is also formed, and there oxygen which is present in the atmosphere, okay, the atmospheric oxygen, it is reduced to form water in the cathode region. Okay, the atmospheric oxygen which is present in the atmosphere, okay, it is reduced. If you remember the definition of reduction, that was gaining of hydrogen, isn't it? So here atmospheric oxygen, okay, it gains the hydrogen, okay, hydrogen gets added to it, and water molecule is formed. If you try to understand the reaction which is written below, O2, that is the atmospheric oxygen which is in gaseous form. Okay, now as moisture is present on the iron nail, so hydrogen ions in the aqueous form it is present. Okay, so 4 hydrogen ions come together with 4 electrons, and 2 water molecules are formed, and that is in liquid state. Okay, now in the previous one we have understood Fe is getting oxidized to Fe2 plus, isn't it? That means it has lost 2 electrons, that has become ferrous. Fe2 plus is ferrous. In the previous presentation we have understood Fe2 plus is ferrous. Now these Fe2 plus ions, they migrate from anode region, okay, and they react with water. This Fe2 plus which is formed at the anode region, they migrate from there and they react with water and further get oxidized to form Fe3 plus ions. That means Fe2 plus ions which was formed at the anode region, they migrate from their place. Okay, they react with the water and then they get further oxidized. Further oxidized means they lose more electrons. So Fe2 plus, it loses one more electron, so it becomes Fe3 plus. Okay, and what is this Fe3 plus called? Ferric. Okay, Fe2 plus is ferrous, Fe3 plus is ferric. So ferrous ions, they get oxidized to ferric ions, and then at last these ferric ions get added to water and we get the reddish colored hydrated oxide. Okay, and this is called as rust. You can see the reaction over there. 2 twice of Fe3 plus 4 molecules of water gives the rust formula. Okay, and 6 hydrogen. So let's have a recap how it is done, how the rust takes place. It is not a simple reaction, it takes place by electrochemical reaction. On the surface of the iron, some regions acts as the cathode, some regions acts as the anode. Okay, the positive and the negative terminal. Okay, now the reaction starts at the anode. At anode, Fe get oxidized to Fe2 plus, it becomes ferrous ions. At the same time, at cathode, oxygen, atmospheric oxygen, gains hydrogen and water molecule is formed. Okay, now Fe2 plus ions which was formed at anode, they start migrating from their place. Okay, they react with water and they get further oxidized to Fe3 plus. Okay, and then that Fe3 plus again reacts with water and then they form the rust. So it's an electrochemical reaction taking place. It's a slow process. Now because of this rust, what happens, many of the things get like it the iron material gets damaged. Now we are going to understand the definition of corrosion. Okay, the damage caused to a metal due to substances in the atmosphere such as moisture, acids, air, etc., bringing about its oxidation is called as corrosion. Okay, now this corrosion, it is not like it only takes place on iron, on all the metals corrosion takes place. Okay, but on different metals there is a different way of, like, the rusting takes place on at a different rate and with different components. Okay, for example, for iron it is water and air is required for rusting. Okay, but for other metals some other things may be required, some other gases may be required. Okay, so what is corrosion? It is the damage caused to a metal. Corrosion is nothing but it is a damage caused to a metal. It weakens the metal due to substances in the atmosphere. Okay, it can be any substance such as moisture, acids, air. Okay, which bringing about its oxidation. So mostly when oxidation takes place on the metal by the various components such as moisture, acids, air, so that is called as corrosion. Okay, and this corrosion can be prevented. You must have observed when the window grills they get rusted, what our parents they do? Yes, they paint the window grills with oil paint, if you remember. Yeah, so that means by painting the rusting can be avoided. What happened when we paint the iron material? So there is no direct contact between the air and the iron, and thus for a few days the rusting is avoided. The same way, the ships are also painted at a frequent interval. The ships which are present in the water, sea water, they also get often rusted. Okay, and that is why they are frequently painted to avoid rusting. So that can be done to avoid corrosion. The detailed explanation of corrosion we are going to understand in the another chapter this year itself. Okay, what preventions can be taken and how we can avoid corrosion. There is a vast topic in our next chapter. So there we are going to understand in more detail about corrosion. Okay, so this was all about corrosion. We have studied, let's have a recap. In corrosion we have studied what is we have seen one activity, what two things are necessary for rusting, air and water. Okay, then we have seen how rusting takes place, what are steps, okay, for it, and at last we have seen corrosion ka definition. Okay, now we have the last topic of the chapter. It's a very short topic, students. Okay, so this is the last topic of the chapter, that is rancidity. Okay, this is the last topic. It's a very short and easy topic. Rancidity. Now I'll give you one example. Your mother must be cooking food at home. Suppose someday she has deep fried something, okay, in the oil, and that oil is kept as it is for some days. Okay, it is not used. After 4 to 5 days, when we see that oil, the oil when you use that same oil after 4 to 5 days, okay, so the food which was prepared in that oil, it will have a foul odor in it, and the taste of the food will also change. Okay, so that is called as rancidity. Okay, foods that contain oil or fat generally lose their taste or acquire an foul odor if kept for a long time. This change in taste is termed as rancidity. See the chips, wafers, or when your mother make chiuda and all. Okay, so when for a few days it will be fresh, but after a particular days, like if it is kept open, so after that we uh, if you eat chips after like 10 to 15 days, the same chips will have a foul odor and the taste will change, isn't it? So that is called as rancidity. So we should never use the oil which is already used for deep frying and all. Okay, 1 to 2 day we can use, but after that it becomes toxic. Now it is having some bad effects as well. So what are the bad effects of this rancidity on our health? Let us see. Now this rancid fat, it can lead to vitamin deficiency if you are consuming that kind of food. Okay, rancid food if you are consuming, then the vitamin in your body, okay, it will get deficit. Okay, deficiency of vitamin will take place. You will start having the muscle pain. Okay, third, the most common thing, that is diarrhea. See, you must be observing sometime you go out to eat something. Okay, suppose you are eating some snacks. The snack, suppose take example of a vada pav. So that, suppose the vada is fried in the rancid oil, that means the oil which was kept for 5 to 6 days, and in that same oil, if the um what we say, if the in the same oil the vada is fried, so if you consume that kind of food stuff, you are going to suffer from diarrhea. See, it frequently happens with most of us. So we have to be extra careful when we are eating the outside food, what kind of what quality of things they are using. We should always have a look on that. And then also you can have heart related ailments if you are consuming the rancid fat. So it is very dangerous. We should always be careful while using the food, while eating the food. Now how we can prevent it? See, first of all, by keeping the food item away from the sunlight. Okay, sunlight also affects. Because of sunlight the rancidity increases, and because of which the taste and um, the smell changes of the food. As well as by using antioxidants. Now what are antioxidants? They have given example: vitamin C, vitamin A, and citric acid. These all are the antioxidants which can be used to you know keep the food safe for a longer time. You must be remembering what is citric acid. The common name is vinegar. So when we make some see when we the I'll give you example. um, the canned food, okay, it always have citric acid present in it or various antioxidants, so that the food remains fresh for a longer time. And the third is by storing in airtight container. This is the best thing we can do at home. By storing whatever we the food stuff, whatever like dry chips and all we are consuming, it should always be stored in airtight container. As well as the oil, suppose once the oil is used, that used oil should also be kept in the airtight container, so that the oil will not react with the atmospheric air. Because once the oil starts reacting with the atmospheric air, that oil will become rancid. Okay, so the oil also that your mother uses at home, okay, that used oil, it is suggested it should be used within 1 to 2 days. Or if you are using it more than 2 3 days, where if it happens, actually it should not happen, but if it happens, then it should be tightly, it should be that oil should be kept in a airtight container, so that it does not come in contact with the air. Okay, and this is how rancidity can be um, what we can say, prevented. Okay, so in rancidity we have understood what is rancidity. Okay, the definition of rancidity: the change in taste and the smell, that is called as rancidity. What it can lead to, it can lead to what problem you can have in your body because of rancid food, and how it can be prevented. Okay, So by this, my dear students, we have finished by this chapter, chemical reactions and equation. Okay, you will get an assignment for the last topic as well. I hope you are completing all your assignments on time. Practice all the assignments and study at home. Okay, be safe, stay at home. Sai Ram, students.